Welcome back. In this video, I will show you the practical use of references. Previously, we saw how to declare a pointer and a reference. We saw what's the use of pointers and references. That is how to access the memory allocated for a particular variable using pointers and references and modify its value. Now we will see its practical use by looking at the difference between pass by value and pass by reference within the context of function calls. So in this video, I will also introduce you to a few different concepts in functions. First, we will look at how to initialize parameters of a function with default values. Then we will look at what function overloading is, what are the different ways of creating overloaded functions. And finally, I will introduce you to vectors in C++. Previously, we were using fixed size arrays to store a list of values. From now on, we will use std::: vector to create resizable containers that can hold a list of values. So first, let's look at how to specify default parameters for arguments of a function. So in line 10, I'm declaring a function called clamp_angle. It's returning a double, and it accepts three arguments or three parameters. The first parameter is angle_in_degrees, so it's angle in degrees. The second parameter is minimum_angle, and the third parameter is maximum_angle. Now notice the second and the third parameter have a default value. That is, minimum_angle is equal to 0, maximum_angle is equal to 360. What this means is, when we are defining the function, we are providing a default value for these two arguments. So the user has a choice now. The user can call this function in three different ways. The first way is to call the function by providing only a single argument, which is angle in degrees. The second way is that the user can provide two arguments, which is the first two arguments, angle in degrees and minimum_angle. So this time the default value will be used for maximum_angle, or the user can provide angle in degrees, minimum_angle, and maximum_angle, wherein the user provided values will be used within this function call. So by providing a default value to a parameter of a function, we can provide flexible ways of calling this functions. So either the user can override this default value and provide a new value, or the user can choose to use the default value. Now the function is checking whether the angle in degrees is between minimum and maximum angle. If it's between minimum and maximum angle, it will return the angle in degrees back. If it's greater than the maximum angle, it will return maximum_angle. If it's less than minimum_angle, it will return minimum_angle. So the function will clamp angle in between minimum and maximum limit. Now let's see how to call this function in three different ways. Before that, I want to mention that the parameter list should be there is a specific order in which you need to provide these parameters for a function call. That is, all the default values should come after the non-default values are declared. So suppose you want to declare it in the following way, wherein first I will provide minimum_angle and then angle in degrees and then maximum_angle. Now notice when I try to compile this function, I should get a compilation error. The error says that the second parameter for this function has a missing default value. So in order for this function to compile, you need to first specify the parameters which don't have a default value at the beginning, and then provide all the parameters that have a default value at the end. Now let's go to the main function and see how to call this function clamp_angle in different ways. So in the main function, I'm declaring a variable called angle. Its type is double. It's initialized to value equal to 90. Now I'm calling clamp_angle in three different ways. First, I'm only passing one argument to this function, which is angle. Second, I'm passing all three arguments, wherein I'm passing angle, minimum and maximum value. So now I want to check whether angle is between 30 and 60 degrees. Finally, I'm only passing two arguments to this function, where I'm passing angle and minimum value, which is 120 degrees. So now I want to check whether angle is between 120 and 360 degrees. Now let's execute this program and check what will be the return values for each of these three function calls. Since angle is equal to 90 and first time we are checking whether it's between 0 and 360, the output should be equal to 90, which is what we see here. Next we are checking whether 90 is between 30 and 60. Since 90 is greater than 60, it should be clamped to 60, so the output is equal to 60. Finally, we're checking whether 90 is between 120 and 360. Since 90 is less than 120, it is clamped to 120. So this showed us how to use default parameters to this showed us how to provide default values to parameters when we define a function. So it's important that you provide default parameters when you're defining the function, and then the default parameters allows us to call the function in few different ways. Now let's check what's the difference between now let's check what is function overloading via an example. So here I'm declaring a function called my_max. It accepts two integers a and b and then returns an integer back. So the function will check whether a is greater than b. If a is greater than b, it returns a, otherwise it returns b. Now suppose I want to pass doubles to this function. That is, I want to compare whether two floating point numbers are greater than, which of the two floating point numbers are greater than the other. I will not be able to use the same function. Now, in order to pass doubles, I need to create a new function. Now, C++ provides us a way to create a new function with the same name by using the concept called function overloading. So here I'm creating a new function called my_max, which returns a double and accepts two arguments which are of both type double. So notice the name of the function is the same, which is my_max. However, the arguments are now doubles instead of integers. The body of the function is again the same. It checks whether a is greater than b and returns a, otherwise it returns b. Now to have overloaded functions, the requirement is at least one of the arguments in the function call should be different. So what this means is the data type of one of the arguments should be different. So suppose I copy the same function again, and this time I just swap a and b. Now let's see whether this compiles as an overloaded function. Now notice the function does not compile. The reason why is because the signature of this function is int my_max in parenthesis int, int. So that's the signature of the first function that we declared and defined. The signature of the second function is still the same. We have the integer return type, the function name is my_max, and then it accepts two arguments with both of type int, int. So just by swapping the changing the order of the arguments is not sufficient to overload a function, or it's not sufficient to create an overloaded function. To have an overloaded function, you need to change the data type of the arguments. So it's also not sufficient to just change the data type of the return type. This again will not compile. So notice again, the overloaded function double my_max of int, int differs only by return type from int my_max of int, int. So to have an overloaded function, you need to change the type of the parameter and not the return type. So you can have the same return type with different parameter types. That is, you can still have an int with one of these being a double. Now this should compile. So here I'm changing the signature by int my_max double, int, which is different from int my_max int, int. So just to recap, when you want to have more than one function with the same name, you need to make sure that one of the arguments of the function has a different data type.